Hi everyone, welcome back to your channel Vegyanghar. We have already covered the Section A and Section B of the IIT JAM 2020 Biotechnology paper. Today we will be talking about Section C, that is the NAT or numerical answer type. This section has 20 questions in total, and for these questions the answer is a real number which needs to be entered using the virtual keyboard on the monitor. No choices will be shown for these type of questions. Now the question 41 to 50 of this section will carry 1 mark each, and the questions 51 to 60 will carry 2 marks each, making this section a total of 30 marks. Guys, let me tell you, this particular section is very important along with the multiple select question because your rank will depend on how well you perform in these sections. Let's begin. The first question is, the generation time of E. coli is 20 minutes if there are 10 to the power 6 E. coli present in an exponentially growing synchronous culture, then the average time in minutes required to obtain a final population of 4 into 10 to the power 6 E. coli is. For an exponentially growing population, we know that Nt is equal to N0 2 to the power T by D, where Nt is the population at time equals to T, N0 is the population at time T equals to 0, that is the initial population. D is the doubling time or the generation time, which is given here as 20 minutes, and T is the time that we have to calculate. So when you put these values into the formula, you will find that T comes out to be 40 minutes. The answer is therefore 40. So you will have to put this numerical value 40 from the virtual keyboard that you'll have as the answer for this question. The next question is, the solution to this given integral rounded off to 2 decimal places is. Now to simplify, we will put 1 plus y square is equal to t. On differentiation, you'll find 2y dy is equal to dt. Now because we have changed the variable, we will have to change the limits also. So putting y equals to 0, t will be 1, and when you'll put y is equal to 1, t will be 2. So now the integral becomes root t dt from the limit 1 to 2. Now root t means t to the power 1 by 2. And we know when there is a to the power n, it becomes a to the power n plus 1 divided by n plus 1. So it's t raised to the power 3 by 2 divided by 3 by 2, that becomes 2 by 3 in multiplication. Put the values upper limit minus lower limit and you'll find the answer to be 1.22. So the answer in the answer key will be given as 1.20 to 1.30, any value in between. So 1.22 will be correct. The next question says that A is a 2 by 2 matrix, that is sin theta, cos theta, sin theta, and A plus AT minus 2I is equal to 0, where AT is the transpose of A and I is the identity matrix. The value of theta in degrees is. Now to find the transpose of A, that is AT, we simply have to reverse the column and the rows of A. It comes out to be the same matrix as A. I will be the identity matrix. Now put these values in the given equation. Because this is equal to 0, we will find that 2 sin theta is equal to 2 or sin theta is equal to 1. That means theta is equal to 90 degree. The answer will be 90. Moving on. Truth table of a logic gate is given below. In a truth table, there are 2 inputs and there is 1 output. The value of x in the above table is. Now this is simply an example of NAND gate. So x will come out to be 1. The answer is 1. The next question says that consider 2 particles, each of mass 20 gram. The first particle is moving with the speed 10 meter per second along a one-dimensional track in the positive x direction and collides with the second particle at rest. Assuming that the collision is elastic, the speed in meter per second of the first particle after collision is. So m1 is equal to m2, that is 20 gram. u1, that is the initial speed of first particle, is 10 meter per second, while u2 is equal to 0 because it is at rest. So after collision, v1 will be equal to what? Now, because it is given that the collision is elastic, so momentum will remain conserved and kinetic energy will also remain conserved. So when momentum remains conserved, m1u1 plus m2u2 is equal to m1v1 plus m2v2. This will give us an equation that is 10 is equal to v1 plus v2. When kinetic energy remains conserved, that is half m1u1 square plus half m2u2 square is equal to half m1v1 square plus half m2v2 square. That will give us a second equation, that is 100 equals to v1 square plus v2 square. When you will solve these two equations, you will find that v1 is 0. So the answer is 0. That means the first particle after collision will come to rest. Moving on. In the following reaction, the values of delta H and delta S at temperature 25 degrees Celsius are minus 30.7 kcal per mole and minus 16 cal per Kelvin per mole respectively. The value of delta G in kilocal per mole of the reaction rounded off to 2 decimal places is. Now we know that the formula for free energy is delta G is equal to delta H minus T delta S. Delta H is minus 13.7. Temperature we will take in Kelvin, so 25 degrees Celsius is equal to 298 Kelvin. And here, because the energy is given in kilocal, we will have to multiply the value of delta S into 10 to the power minus 3. Solving this, you will get minus 8.93 as the value of delta G. So the answer can be any value between minus 8.90 to minus 8.95. So minus 8.93 will be the correct answer. The next question is, the volume in ml required to prepare 350 ml of 1x buffer solution from a 50 times concentrated buffer stock solution is. We know C1V1 is equal to C2V2. Here C represents the concentration and V represents the volume. So we have to prepare a 1x buffer of 350 ml volume from a 50x concentrated buffer stock solution. So the volume required to prepare this is 7 ml. The answer is 7. The next question says, a compound microscope has its objective with linear magnification of 10. In order to achieve a final magnification of 100, the angular magnification of the eyepiece should be. Now, the magnification formula is m1 into m2. For the total magnification of 100, the magnification of m2 should be 10. So the correct answer is 10. The next question says, the decimal reduction time DRT or D value of a bacterial culture is 1 minute. If a suspension of the bacterial culture contains an initial population of 10 to the power 6 cells, then the time in minutes required to reduce the number of bacteria to 10 by heat treatment is. Here NT is equal to N0, 1 by 10 to the power T by D. NT is the population at time t, that is 10. N0 is the initial population, that is 10 to the power 6. D is the decimal reduction time, that is 1 minute. And T is the time we need to calculate, or the time that is required to reduce this number by 10. So T comes out to be 5. The answer is 5. The next question is, the median of y in the following data is. Now we are given 6 numbers. we arrange them in the ascending order. Median is n by 2th plus n by 1 by 2th divided by 2. Here the n by 2th and n plus 1 by 2th numbers, that is the third and the fourth numbers, are 14 and 16. So 14 plus 16 divided by 2, the median comes out to be 15. The answer is 15. Moving on. A variable number of tandem repeats, VNTR locus, has 15 different alleles. The number of genotypes possible in the population for this VNTR is. Now, the number of possible genotypes is given as n into n plus 1 by 2, that is 15 into 16 by 2, which is 120. The answer is 120 for this question. The vibrational frequency expressed in wave number of HCl is 2990.6 cm inverse. Assuming that the force constant is same in both the cases, the vibrational frequency of DCl is. Now the formula for vibrational frequency is 1 upon 2 pi c under root k by mu. Here c is the speed of air, k is the force constant, and mu is the combined mass, that is equal to m1 m2 divided by m1 plus m2. Now it is given that for HCl it is 2990.6 and we have to find the vibrational frequency for DCl. In case 1, m1 is equal to 1, m2 is equal to 35, so mu1 comes out to be 0.97. In case 2, that is DCl, m1 is equal to 2, m2 is equal to 35, and mu2 comes out to be 1.89. Now, to find mu2, we will simply put the values in this formula and it will come out to be 2147.12 cm inverse. That is less than the HCl value. So the answer can be anything between 2100 to 2200 and your answer will be correct. Moving on. The length of transverse and conjugate axis in a hyperbola are 6 and 8 respectively. The eccentricity of the hyperbola, that is the E value, rounded off to 2 decimal places is. Now in a hyperbola, this B is the conjugate axis and the A value is the transverse axis. So B square is equal to A square E square minus 1. When you substitute the values of 8 and 6 in this equation, you will find the value of E to be 1.66. The answer could be any value between 1.60 to 1.80. So 1.66 is the correct answer. Moving on to the next question. The solution to the limit is. Now we will have to rationalize this limit. So we multiply both the numerator and the denominator by 2 plus under root 4 plus x, and we will find that the limit when x is equal to 0 comes out to be 1 by 4, that is 0.25. Moving on. The next question says the average value of function f of x is equal to under root 9 minus x square on the interval minus 3 to 3, rounded off to 2 decimal places is. Now you can find the value of this integral using this formula. Under root a square minus x square dx is equal to x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. Here a will be 3 and the x will be the interval values, that is minus 3 and 3. Now because this interval is over a range of 6 units, to find the average value we will have to divide this I value by 6. So 14.13 divided by 6 comes out to be 2.35. The answer can be anything between 2.30 to 2.40. So 2.35 seems to be the correct answer. The next question is, a bouncing ball is dropped from an initial height of h meters above a flat surface Each time the ball hits the surface, it rebounds the distance r into h meters and it bounces indefinitely. Consider the value of h is equal to 5 meters and r is equal to 1 by 3. The total vertical distance up and down travelled in meters by the ball is. Now, the total distance will be h plus 2 into r plus h because we have to calculate both the up and the down distance. Then it will be r into the h, that is the RH. So it becomes an infinite GP. So it is h plus 2hr 1 upon 1 minus r. When you will put the values of h as 5 and r as 1 by 3, you will find that the total distance travelled by the ball is 10 meters. The answer is 10. The next question is, 1 point charge q each is placed along a line at 3 different points, x equal to 0, x equals to 2 and x equals to 6 nanometer. The force between the two charges separated by 2 nanometer is 2 piconewton. The magnitude of force in piconewton on the charge in the middle due to the other charges is. So as you can see here, there are 3 charges at x equal to 0, x equals to 2 and x equal to 6 nanometer positions. Because the force between the two separated by 2 nanometer distance is 2 piconewton, so we can say that F12 is equal to F21, that is K Q1 Q2 by R square is equal to 2 piconewton. In this case, Q square comes out to be 8 by K. Now we know that the F net on Q2 will be F12 minus F32, that is K Q1 Q2 by 2 square minus K Q3 Q2 by 4 square. So solving this, you will find that F net on Q2 will come out to be 1.5 piconewton. The answer is 1.5. The next question says, the energy of the electron in hydrogen atom in its ground state is 13.6 electron volt. The energy required in electron volt to move the electron from its ground state to the first excited state, rounded off to 2 decimal places, is E is equal to minus 13.6 Z square, 1 minus n square n1 square minus 1 upon n2 square electron volt. Now n1 is 1, that is ground state, n2 is 2, that is the first excited state, and Z will be 1, that is the atomic mass will be 1 because it's hydrogen atom. So E will come out to be 10.20 electron volt. The answer could be anything between 10.0 to 10.4. So 10.20 electron volt is the correct answer. The next question says, at a given time t, the velocity and acceleration of a particle undergoing simple harmonic motion, that is SHM, are given by, assuming all the quantities are in SI units, the amplitude of oscillation is. Now, we can think of it as xt equals to a cos omega t plus theta and vt is equal to minus a omega sin omega t plus theta. Now, when you will compare the values, you will find that a omega is given as 100 in the question, and omega is equal to 20. So amplitude of the oscillation will be 100 by 20, that is equal to 5. The answer for this question is 5. Moving on. Now, in an enzyme catalyzed first order reaction, the substrate conversion follows an exponential pattern such that 80% of the substrate is converted in 10 minutes. The first order rate constant in minute inverse of the reaction rounded off to 3 decimal places is. Now Nt is equal to N0 e to the power minus Kt because it is an exponential reaction. Nt is the amount of substrate remaining after time t. So because 80% of the substrate has been converted, so Nt or the remaining will be 20. N0 is the initial value, that is 100, and t is already given as 10 minutes. So when you will solve this, you will find that K, or the rate constant in minute inverse, is 0.16 minute inverse. So the answer, as I have already told you, can be any value between 0.16 to 0.17. So the 0.16 will be the correct answer for this question. That's all for now, guys. We have completed the IIT JAM Biotechnology 2020 paper. Thank you so much for watching this video. Don't forget to like and share, and do subscribe to the channel. We will be soon back with the 2019 series of the same IIT Biotechnology. Thank you so much for watching.